What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be starting chapter 7, looking at the first lesson, Angles of Polygons. You are going to get a chapter 7 theorem sheet, so you're going to keep up with that throughout chapter 7 and then be able to use that to reference it later. Today our objectives are focusing on interior and exterior angle measures of polygons. First thing we want to make sure we understand, consecutive vertices are two vertices of a polygon that are endpoints of the same side. Diagonals are segments in a polygon that connects two non-consecutive vertices. It doesn't necessarily have to connect it exactly halfway across, just as long as they're not side by side and you're connecting one vertice to the other. The next thing we're going to talk about, and this is one that you can fill in on your theorems worksheet, is theorem 7.1, interior angles theorem. When you want to find the sum of the measure of the interior angles, you can take the number of sides, subtract 2, and multiply 180 to find the total amount of degrees. So for example, this shape here has 1, 2, 3, 4, 5, 6, or you can say even 6 vertices. So since this is a 6-sided figure, you could do 6 minus 2 and then times that by 180, and that'll give you your total degree measurement. So what we're going to try here, it says find the sum of the measures of the interior angles of the figure. So what we first have to do is count all of the sides. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got 10 sides. So because we have 10 sides, we can plug that in to our formula. 10 minus 2 is 8, and then 8 times 180 will give us 1,440 degrees. So that would be the sum of the measures of all interior angles. This one shows the sum of the measures of the interior angles of a convex polygon is 180. Classify the polygon by the number of sides. And I kind of did like 2 examples in one here, so we're going to talk about this side first. Okay? If you know the interior angles equal 900, then we can set our equation up and say 900 is equal to n minus 2 times 180. What I would do first is I would try to get 180 with 900, so I'm going to divide both sides by 180, which means n minus 2 can now be broken out of the parentheses, and I'm going to get 5. Then I'm just going to add 2 to both sides, so I get 7 is equal to n, and this would be considered a heptagon. Okay. Over here, though, it says find the value of x in the diagram. What we want to know first is how many sides does this shape have? 1, 2, 3, 4, 5, 6. So since this is a 6-sided figure, we're going to take 6 minus 2 and times that by 180 to see how many degrees I should have. 4 times 180 gives me 720. So what I need to do now is take all these and add them together. So 145 plus 118 plus 115, 111, 124 gives me 613. So I just have to subtract that from 720, and I'm going to get my final result of 107. So x is equal to 107 degrees. The next part just talks about different types of polygons. So we're going to do some sketches here. So we have an equilateral polygon. All sides are congruent. I'm going to do just a pentagon. That's the easiest one to draw. That's not necessarily drawn to scale, but I'm showing that with my tick marks. All sides are congruent. In an equiangular polygon, all angles would be congruent of the interior. So again, just showing that with my angle arcs here. And then a regular polygon, or this one actually doesn't show equiangular. Maybe if we did a hexagon, that'd probably be better. So not necessarily all the same side lengths, but all same angle measurements. And then a regular polygon is a convex polygon that is both equiangular and equilateral. So I'm going to redraw that hexagon here and just show that we have all the same sides, equilateral, and all the same angles, equiangular. Okay? So going to part 2 of our shape here, it says a home plate for a baseball field is shown. Is the polygon regular? Why or why not? We're going to say no because the angle shown are not all equal. We also don't know anything about the sides. Okay. Then it says find the measures of C and E. Well, I know that these three measures are 90 degrees. So these are 90, 90, and 90. And because I know this is a five-sided figure, I can use 5 minus 2 times 180 to tell me how many total degrees there should be. 3 times 180 is 540. And I'm going to subtract my 270, which is my 90, 90, 90. I am left with 270. And then I need to just split that evenly between E and C. So I'm going to get both E and C can be equal to 135 degrees. Okay. The last thing we're going to talk about are exterior angles. This will be your next one on your sheet, 7.2 theorem. The sum of the measures of the exterior angles for a convex polygon, one angle at each vertex, is 360 degrees. So for instance, if this is a five-sided figure, each one of these would add up to be equal to 360 degrees. So looking at this example down here, we know that we have 5x, 62, 35, 69, 41, and 58, and they should all be equal to 360. All of my like terms together I can add to get 265. Subtract 265. I get 95. And then divide by 5, I'm going to get 19. So x is equal to 19. If I wanted to find the value of that angle, I would just plug x back into the equation, and that would be 5 times 19, which would give me 95 degrees anyways. Last two examples. A trampoline is shaped like a regular dodecagon. Dodecagon means 12. The measure of each angle can be found by doing 12 minus 2 times 180. So that would be 10 times 180, which is 1800. But each interior angle would mean this is my total sum, right? Because whenever we find the total interior angles, we take that minus 2. So to define that, we would then have to divide that by 12 for each interior angle. So 1800 divided by 12 will give me 150 degrees. Okay. For the exterior angles, I know this is a 12-sided figure, so that means I'm going to have 12 exterior angles. They should all be equal to 360, and all I'm going to do is divide those by 12 and get x is equal to 30 degrees. Okay? Hopefully this video helped you with your interior and exterior angles of polygons. Thanks so much for tuning in, and we'll catch you next time. Have a great day.